Here's the question then, and I've got it summarized on over the page. So we've got this region R bounded by these values. Let's draw a sketch. So we've got our sine 2x. When it's pi over 2, this will go to sine 180, won't it? Sine pi. So we're going to need to draw to round to 180 for the sine function. So it's going to go up and come back down, isn't it, the sine function? So there's just a casual sort of informal sketch of it rather. X and Y, 0, so that we can just see the region. This would be pi over 2, wouldn't it? Because sine 2 pi over 2 is sine pi, which is 0. And there's the sine function. And pi over 6, we can put here, say, pi over 6. And there's our region. So this region R is the region R then. Volume generated R is rotated 360 degrees, so it's going to turn around like so. And there's a segment of the volume. Okay, thickness delta x. This height here is y. So here then the volume generated is equal to sum these disks between pi over 6 and pi over 2. Pi r squared, isn't it? Pi r squared is the area times the thickness delta x, so it's integral pi y squared dx, which equals, now we've got the integral pi over 6, pi over 2, put the pi outside here, pi lots of, y squared is sine squared 2x dx. Okay, let's use the double angle formula then. Sine squared. Now, the double angle formula is cosine 2x is equal to 1 minus 2 sine squared, isn't it? So the formula in general then, move this over just from memory, we're just getting our formula here, is equal to, so move that over, it would be 1 minus cos 2x, but then we'd divide by 2 all the way through, wouldn't we? So that's just for memory, sine squared x, and we've got sine squared 2x, so let's put that in then, pi over 6, pi over 2, use this formula, it's going to be a half, and it's sine squared 2x, so this will be double, the 2x will be 4x, won't it? Half cosine 4x dx. So that equals then, integrate x over 2, integrate this, cos integrates to sine. Now the 4 comes out, we've got a half, so we'll need an eighth, won't we, to generate the half when the 4 comes out. And that needs to be evaluated between pi over 6 and pi over 2. Don't forget it's pi lots of, so there's a pi lots of here, and that's easy to forget, which I illustrated well then for a moment. So it's pi, top value, take bottom value. Pi over 2 in here, so it's pi over 4. And then pi over 2 in here, sine 2 pi. 4 lots of half pi is 2 pi, sine 2 pi is 0. Bottom value, pi over 6 in here, pi over 12 then. 4 pi over 6 minus sine 4 pi over 6 is sine 2 pi over 3, isn't it? 1/8 of sine 2 pi over 3. So let's tap that in. Sine 2 pi over 3, I'm going to keep it in degrees mode because I'm in degrees mode. 2/3 of 180 is 120. Root 3 over 2. Over 2. So what have we got then? Pi over 4 minus pi over 12 plus root 3 over 16. So that's equal to pi. 3/12 minus 1/12 is 2/12. 2/12, which is 1/6. Pi over 6 plus root 3 over 16. So there's a 2 common there which we could take out. Pi over 2. Pi over 3 then, plus root 3 over 8. And that would be a volume, so it would be units cubed. So let's type that in the calculator then. I'll put the calculator out of the way over here. So what have we got then? We've got pi over 2 times bracket pi over 3 plus root 3 outside the square root divided by 8 close bracket equals 1.985. We need to do it to 3dp. 1.985, and that was units cubed, as we said, to 3 decimal places.